Okay. Hey, thanks for sticking around. Yeah, if your brain isn't completely blown away by like client-server programming, now we got some more mob and pair programming. So here is tonight's kata. Oops. Show kata description. There we go. Oops. Oops. Oh, I don't know how to use. Oh, here we go. Wait, Java. Does that work? Oh. I have to admit, this website is not terribly conducive to my browser. It uses lots of JavaScript or something like that. Huh. Does it work better in Safari? Oh, wait, there was a way. Yeah, does this... Yeah, for some reason it works on this. I don't know. Okay. I'm going to post it into a Google community posting anyway, so we can do it. Okay. So, yeah, there. Okay, let's go back to the coding dojo and work in pairs or mobs on another kata. So this is let's see here. So this example is going to be creating a calculator which uses reverse Polish notation. It's not an ethnic joke. There was actually a Polish mathematician that came up with this. But and so anyway, the way it works is that you have an expression that is expressed in postfix notation, meaning that you have all the operators on the left, and then the operand is after the operators. And so then when you've got an expression, an expression like 5, 1, 2 plus. That actually, the plus, it's still a binary operator. So this is the postfix way of saying 1 plus 2. So 1, 2 plus. And then when you've got 4 times, this all right here is the same way of saying, basically 1 plus 2 times 4 over here. Okay, and so then if anybody has ever used Hewlett-Packard calculators, this makes complete sense. My wife, who's an actuary, thinks this way. I'm like, that's the craziest thing I've ever seen. Anyway, pretend that you're working at Hewlett-Packard in 1970 and you're writing code for calculators. And so basically, when someone with an advanced degree in mathematics puts in this expression, you should evaluate this expression and then return its value. So let's see here, a couple of things. Always assume, or you can assume that there are always spaces between numbers and operations. So you don't need to worry about the fact that there isn't a space between the 3 and the plus. Empty expression should evaluate to 0. And the basic for function mathematical operations. And then, don't worry about division by 0 or, funny things like knotted numbers. So, I recommend that you get started using the student archetype again to start your Maven project. Or heck, if you want to use the same Maven project as you did last time, that's cool too. No big deal there. Okay. So, any questions? No? Okay. Well, let's get to it then. Please break up. I've got the keyboards up here. If you don't want to share a laptop, and we'll check in probably like half an hour. See what we're doing. Okay. Oops. Where did the Google Hangout go? Okay. Who wants to go first? How about you guys right here? I don't know who's who. Is that who's? Yours? Awesome. Okay. Let's see here. Wait a second, though. Am I getting your audio? Are you on mute?
I'm muted.
Take yourself off mute so we can hear you. So yeah, everybody should have their speakers off, but their microphones.
All right, can you hear us now?
Yes, I can. Great.
All right, so I guess, yeah, this is, yeah, the one that's. So our general approach was, one, we assumed that we weren't going to get past a bad string. Obviously, you can implement error checking. Assume, if you wanted to assume that there was, just you're instantly given an operator and nothing to operate on or those kinds of things. We kind of abstracted that away for the moment. So our general approach was to use a scanner to scan through the string. The thing we noticed is if you used a stack for the string that you're given, you can start from left to right, pushing items onto a stack. And the minute that you hit an operator, you can pop the top two items on the stack and perform that operator on them. And then the result of that operation is push back on the stack. So pretty much you're going to keep growing a stack of integers. The minute you hit an operator, you're going to perform it on the top two items and replace that back on the stack. So it's going to keep growing until you hit an operator, and then it'll shrink down one size. And another limiting assumption we made is that you're going to, at the very end, have just one int left on your stack. So to perform that, I'm not sure if you can see my mouse, but not really. But starting at the top, try to get that out of the way. We have a scanner S where the expression being passed in is string. The scanner is nice in that you can look at each item broken up across the spaces. So in the start of our while loop, s.hasNext is the next item within that expression. So we set the string token equal to s.next just to store as a variable. And then we used a switch statement where we checked for the case of the four operators we were given. And then we made that simplifying assumption that if it wasn't one of those four operators, it was a valid integer. So kind of looking at the case for the plus, you can push onto the stack the sum of the two items you popped from the stack. The same is true for the multiplication. For the divide and the minus, we ran into a bug, which it sounded like a few others did, where the order that you pop the items off on the stack is not the order you want to perform a divide or subtraction in. So we made a temporary variable to capture that first item being popped that we want to use as a divisor or the second half of the subtraction. And then our default case, we're just assuming it's going to be an integer, and we just parse the character or the string into an integer and push that onto the stack. And then I think if I can scroll down here, we just return the stack.pop. And we should have some test cases somewhere around here. And I don't know if you'll be able to see the command line, but oh, there we go. Our tests are pretty simple, but they test each of the four functions, and then they also test the happy path. And we also decided to use just integer division. So 10 divided by 3 just equals 3. Again, you could probably flex this depending on how deep you want to go on that. If you wanted to use float arithmetic or anything like that. Yeah. So, any questions?
Very cool. Did you do a test driven, or did you write the implementation first?
Mostly wrote the implementation first, and then the tests afterwards. We could have done a test driven.
Did your tests reveal the issue with the order of the operands?
It did.
Okay. So.
Yeah, that was the part, kind of the head scratching of why isn't this outputting what we wanted. So, yeah, it was nice.
Yes, these guys?
Oh, nice. Okay, who's next? Oh, sorry. Are you not sharing your screen yet? Share your screen. There we go. Yep. I don't know either.
When did the Hangout, did you share your whole screen or?
I shared my.
Oh, wait.
I shared my whole screen.
That's weird. Like definitely in. That's funny.
Solid, yeah.
Okay, share. Yeah, go into the Hangout and share your screen again. Okay. Hey, nice.
It's essentially the same code that these guys have. The big difference is we just I guess we named our variables right and left. Right up, right up, up, right up. Just make it more descriptive. But otherwise, it's the same. The code is the same.
And we assume you have an array of strings rather than a single string, as if you were just using it as a command line.
Yeah, we're taking the input from the command arguments
Oh,
instead
okay.
of
So yeah, the command line parser do the parsing for you.
Started doing it test driven, but I guess we lost ourselves at some point. We did also
Well, we kind of had to like finish it out to get a test pass, so
Okay.
mostly test driven.
We heard you guys kind of have the same issue of the order in which it pop things off.
Yeah.
Did you find that way through the tests?
Yes.
And we did.
So, execute that.
Sure. Let's see. Test run. That's nice.
Then we have this one test where we are expected to be these capture exception was
Ah, interesting. Okay. Nice. Cool. Anything for these guys? Any questions, comments? Okay, right on. Okay. And last but not least.
No, we're least because we did do string test-driven development. It was a lot slower. So we just started with empty string returns basically a zero result. So we wrote that into it, and so that kind of was this little section here, and then. And then we had a single number, and then started creating a regex to handle that. And so we got the regex working, then we had to handle the negative number, so we had to update the regex to take the single negative argument, or 0 or 1 negative argument.
Oh,
And
interesting.
then we started to consider, more than one argument. So we thought we'd add an exception when it's malformed. So we did that. And that's part of it.
Cool. Go back to your code again. Where you had that regular expression. I just want to take a look at it.
So here we're just handling
Yep.
numbers. Once we did get a multiplier or a divide, we have to
Good.
kind of add that in and expand the regex. Just
Cool.
say those negative, positive and negative numbers. The slash D maybe is questionable. What's the slash D do?
That's
digits.
digit.
Oh, that's the digit.
So
that
you get
means
0 through 9.
more
So
digits.
minus 0. Yeah. Can anybody think of an alternative implementation of that logic right there?
Minus question mark slash V star.
Anybody think of an implementation that doesn't use a regular expression? I have to admit, I'm one of those people that like never really learned how to use regular expressions because it was the 90s and people were writing in Perl and I didn't like Perl and then anyway. So
Teach us how to avoid this. So to say.
okay. So you're basically that expression matches that thing. You're basically asking the question: is that string expression an integer? What's another way to do that?
Parsons.
Call parsant, and then catch the number format exception. So, and I guess I don't want you guys to think that like catching exceptions is a bad thing, or having an exception thrown is not like you're going to lose points because there's an exception that gets thrown. And 20 years ago, maybe exceptions were slow, or if you're in C++ today, exceptions are slow. But in Java, that's not the case anymore. So then it might be more readable, and actually might be correct because this thing will this will accept. Oh goodness, like minus if you have like 0, like 4 zeros, that'll parse as a int, which might be a valid int. But anyway, not what I'd expect. But anyway, yeah. So it might be more simple just to call parse int and catch the exception, and then turn around and throw the legal argument exception. But no, that's cool. Okay, great. Any other comments on this? No? Awesome. Golf clap. And, well, I'll share my solution briefly. I too did test-driven development, and so I almost got it. Well, I made good progress on it. So one thing that I did differently, and I don't know if this is good or bad or not, is that my approach was to make 2 passes over the string. So maybe this is just the compiler's guy in me. But where I was going with this is that I take the expression and then I parse it. And so what I do is, I have a stack, so I use a stack, and then I iterate over, I split the expression into tokens, and I parse each token. And here, what I'm building up is a stack, not just of ints, but a combination of ints and then these operator enums. And so I kind of like your way better because it seems a lot more simple. Right, so where I was going was I was going to have this stack of that basically represented the expression as objects, a mixture of integers and these operator things. And then I was going to make another pass over it. I was just going to start popping things off. And then when then it had the same logic as yours, where it's like, okay, I just saw an operator pop up the next 2 things. Those are the operands. Take that result, push it back on the stack. Yeah, and go like that. But I haven't gotten there yet, so we'll see. But nice. Okay, good deal. Pretty good work for an hour. So let's see here. Anything else for tonight? Nope. If not, thank you very much. Please come and put the keyboards away. And have a great week, everybody. We'll see you next time. Bye now.